Again, welcome to Introduction to Data Mining course. This is ITS 632 class. In these lectures, we're going to cover data preprocessing, which is one of the steps in data mining process or knowledge discovery from database system. Again, these lectures cover chapter 2 of our course textbook. And our main objective is to go through what is aggregation, sampling, dimensionality reduction, feature subset selection, feature creation, discretizations, and also attribute transformation. And before we start, again, there are many steps in data preparation phase. A typical steps normally will involve in the preparation of data mining view, including the following. At least the first step, we are going to, of course, extract and also sample the data from operational database or from the data warehouse. Again, in data mining, we normally don't analyze all the data. We take a sample, part of the data set. So one of the first thing is extracting, and also the data can come from different sources. So we have data selection, then data integration, before data normalization, then data transformation. These are all the steps we do in data preparation phase or data preprocessing phase. So again, first selecting the data, and secondly, again, doing the data preparation by normalization and also transformation. So typical steps will involve in extracting and also sampling data from the operational database or data warehouse. Most of the time, again, data mining, we always get our data from a data warehouse. A data warehouse will be a formatted historical data set about an organization. Also, we have to check the integrity of the data that we extracted and also we sampled. So this will checks maybe perform on an individual data set or after the integration of all the data elements into one data set. So integration of data is one of the major steps in data preprocessing or data preparation. We're integrating the data in this step. The different elements of mining view are integrated into one table or view. Data will come from different sources, and our goal here again is to integrate all these data. Then the next step will be the transformation. So transforming the data and creating a new variables if possible. This operation can be performed on each table extracted from the data warehouse before the integration of the data. Sometimes we call this as improving the model performance. Sometimes this can improve the model performance. So again, the order of the steps is not really important, but we know in data preparation phase, first we need to select our data. Data may come from different sources, and also we can't use all the data. So we have to do sampling. So extracting and sampling our data. Then the next step, we can check for the integrity of the data if there's any errors, etc. Then we integrate the data. Then possibly we normalize and transform the data. And these are the steps that we are going to discuss in these lectures. So again, we will start with the concept of, again, aggregation. So aggregation means combining two or more attributes or objects into a single attribute. This is very good data preparation concept or a techniques, because in this case, we can reduce the data, a data reduction. So the main purpose of aggregation is to reduce it. For example, I may have a data set about customers, and I have a customer age as a field, and also I have a customer date of birth as a field also attributes. So here we have two attributes, but these two attributes have the same data or the same information. Date of birth, if I know the date of birth, then I'll know the age. If I know your age, most likely I can roughly know the year you were born. So in this case, we can do aggregation here, combine the two attributes as one unit. Either we make it date of birth or we make it age. So combining two or more attributes, which is the aggregation, the main purpose again is to reduce our data. So reducing the data, what is the advantage? The advantage will be for the data mining algorithm, because if we have a large dimension of a data set, that's a lot of attributes and a lot of instances or records, it will take the algorithm a very long period of time to make a decision. But normally, if we have a less attributes, it will take the algorithm less time, and also it's going to use computer resources, which mostly will be memory or the CPU processor, less time or less resources. So aggregation, again, the main objective, data reduction. Then also changing of a scale. Example given here, cities. Instead of having cities as a towns or a street name, we can make cities as a region, state, or a country. So in US, let's say we are doing a study in 150 cities around the world, and US have, so for example, again, we are taking a data set, or we have a data set from 150 cities around the world. And in US, maybe we are taking 10 cities are participating in the studies. Well, if we like, and total is around 20 countries from 150 cities. If we want to reduce this data or the attribute, most likely we can change the scale. From cities, we can make it other states or countries. For example, New York State have at least 4 major cities. So if we make it a state, instead of going through all the 4 cities, we go through only one state. So aggregation, the main goal, in this case, changing of the scale also will reduce the amount of attributes or objects we have. And also it will make it more stable data. So aggregated data tends to have less variability. So it's more fixed and stable data. So again, aggregation is combining two or more attributes into a single attribute. And the main purpose is reduction, data reduction, reducing the number of attributes or objects. And this is very good for most data mining algorithms. They are going to use less computer resources, which is memory and the processors. So this is an example of aggregation of a variation of precipitation in Australia. You can see that our first data we have a standard deviation and then the number of land locations. But we can see the scaling from 0 to 5, 10, 15. Now we change the scaling. Instead of being monthly, we change the scaling to yearly. So we can see how it will, again, the two are the same data. But because we change the scale from monthly to yearly, we can see how the yearly shrink, the graph shrinking. But the goal here again is to reduce the attributes or the instances. So we move to the next data preprocessing tool, which is sampling. As we mentioned earlier, mining the whole data and the whole population, sometimes it to take a lot of computer resources and also time of the computer. So the best is to take a sample. So sample is the main technique employed for data selection. And sampling means we are not going to use all the data, but rather we are going to use some amount of the data. So we have to take a sample. And here we say it is often used for both preliminary investigation of the data, and also the final data analysis. And normally, statisticians sample because obtaining the entire set of data of interest is too expensive and also time consuming. So to analyze a population, especially to take information, even the data from a population, is a lot of time consuming and it involves a lot of cost. So sampling is used in data mining because processing the entire set of data of interest, again, is too expensive and time consuming. The same concept or the same reason as statisticians. Statisticians or data analysis, they believe, again, obtaining data from a population is time consuming, very expensive. So there are key principles for effective sampling. One of the main reasons when we are taking sample, we have to make sure that the data is well represented. There's no bias in the data. What we mean by bias is, for example, there's a bill that is passed by the Congress, and the Congress, again, is led by Democrats. Well, if Democrat is passing a bill, the chance that it will pass through the Congress, the House, is good because they have majority. But now we want to see if this bill, the public, American public, support it. So now if I go to a neighborhood whereby we know 80 to 90% of the population are Democrat, and that state or that neighborhood, anytime they have election, Democrats win. If we take a data from that era, most likely we are going to have a bias because they will support the bill because it's a Democratic passing the bill and they are Democrats. So the best way is to go to a place like a swing state, a state that we have 50-50 chance that a Democrat can win, a Republican can win. The population is almost the same. So in this case, we are trying to remove the bias from the decision. So here we say using a sample will work almost as well as using entire data set if the sample is representative. So we want to make sure when we say the sample is representative, we want to make sure that the decision we make in the sample, we can apply it to the population, which means the sample is representing the population. So a sample is representative if it has approximately the same property of interest as the original set of data, which will be the population. So we have different types of sampling. We have a simple random sampling. This is the most common method we use. This means all the members of the population have equal probability of being selected. Whether you're a male, you're a female, it doesn't matter. Then we have sample without replacement, which means if I take the sample from the population, I cannot put it back to the same population again. We have sample without replacement, and that means every person or every object in the population have only one chance of being selected. But sample with replacement, it can be selected more than once because I've got selected. After that, I'll be put back to the population. So I still have a chance of being selected from the population again. So here we say as each item is selected, it is removed from the population, which is sampling without replacement. But sampling with replacement, the objects are not removed from the population as they are selected for the sample. In sampling with replacement, the same object can be picked up more than once. We also have the stratified sampling. Stratified sampling means we are going to divide the sample into stratas or into 2 or 3 parts based on some conditions. Dividing it into 2 parts is what we call the stratas, 2 stratas. That's why it's called stratified sampling. So let's say we want to do a studies and we want to make sure we have the same amount of male and female to be the same. Well, if I use the simple random sampling, since male and female are all mixed together and everybody have an equal chance of being selected, then I may end up even selecting all male or selecting all female, or it can be any amount of the two. But if I need exactly 10 male and 10 female, then I will do stratified sampling. So what will happen is that I will divide or partition my sample into two. We have the male, I will partition my population into two. We have male population and female. Then I'll randomly select both. If I need 10 each, select 10 from each of the population, the male population, female population. So that's why it's called stratified sampling. You partition it into stratas. So this is an example of a sample size. We have 8,000 points, so we can see the density is very dark. It's a lot. But when we reduce it to 2,000, we can see that the density is reducing. Then 500, very reduced. So what sample size is necessary to get at least one object from each of the 10 groups? This is a question we may ask. So again, the main thing, especially when we are doing classification modeling, building a modeling for classification, sample size can make a difference. We can either have overfitting or we can have underfitting. Overfitting means we have too much data that we were able to do. That's the training data. We were able to build a model very good. But when we use the test data to test the model, it's not doing good because we feed the model so much training set that it became used to the system to build a correct system, but to test, it's a problem. Underfitting means we have less data to build a model. So next, we move to what we call the causes of dimensionality. We mentioned this earlier, that if a data set have high dimension of data, which means the attributes are a lot of attributes, it will take the algorithm more time to make a decision. And also the computer resources will be used. So that's why we use the term the curse of dimensionality. The higher the dimensionality, the bad it is to get a good result. So when dimensionality increases, data becomes increasingly sparse in the space that it occupies. So the definition of density and the distance between points, which is critical for clustering and outline detection, becomes less meaningful. So the purpose of dimensionality reduction is to avoid the curse of dimensionality. Because when our data have a high dimension, it affects the algorithm performance. Also to reduce the amount of time and memory required by the data mining algorithms. Also allow data to be more easily visualized and also may help to eliminate irrelevant features or reduce noise. So the techniques we can use to reduce the dimension of the data set or the attributes of the data set. One, these are the three most important techniques which are used in machine learning also. Principal component analysis, singular value decomposition, and also supervised and nonlinear techniques. So with the PCA, which is the principal component analysis, we use the concept from linear algebra. The goal is that we want to find a projection that will capture the largest amount of variation in data. And also find the eigenvectors of the covariance matrix. Now the eigenvectors will define the new space. The goal is that I have the attribute of, let's say, 500, so 500 dimension. And the goal is that I can come up with techniques that I can reduce the 500 to 100 by again defining a new space. So find the eigenvectors of the covariance matrix. Then the eigenvectors will find the new space. So this is an example of dimensional reduction, the effect. When the dimensions was 10, we can see that we can't even see the image. But when it tend to 40, it's kind of like we are seeing the image a little bit. Then when it tend to 80, the image is coming. 120, 160, we almost have the image at 206. So reducing the dimension also can have effect on the quality of our data. So another technique also we call the feature subset selection. So this is another way to reduce the dimensionality of data. So another way to reduce dimensionality of data, we have the redundant features. Redundant means extra items that doesn't have any effect on outcome of our result. So it's redundant. So a redundant can be a duplicate, match, or all of the information contained in one or more other attributes. Example can be the purchase price of a product and the amount of sales tax paid. And also we're trying to remove the irrelevant features. As we said earlier, I have a date of birth and also I have an age. One of them is irrelevant because both carry the same information. So irrelevant features contain no information that is useful for data mining tasks at hand. So student's ID is often relevant to the task of predicting student GPA. So the techniques we can use for feature subset selection, the most famous techniques, brute force approach. Here, brute force means we have to try all possible combination. So try all possible feature subset as input to data mining algorithm. The next we can use the embedded approaches. Here, the feature selection occurs naturally as part of the data mining algorithm. Then we have the filter approaches. Here, the features are selected before the data mining algorithm is run. Then we have the wrapper approaches, where we use the data mining algorithm as a black box to find the best subset of attributes. The next is feature creation. So here we say we are creating a new attributes that can capture the important information in the data set. So again, creating feature creation, creating a new attribute that can capture the important information in a data set much more efficiently than the original attributes. So three general methodology can be feature extraction, then mapping the data to a new space, then also feature construction. So next is the attribute transformation. Here we say the function that helps the entire set of values of a given attribute to a new set of replacement values such that each old value can be identified with one of the new values. So we can use a simple function here for log or standardization and normalization. And we will discuss about this in our next lectures. But the whole concept of a transformation is trying to reduce, for example, we have a data set, and this data set has some values of 1 million. Let's say 1 million, another have a value 10, 1. So I can do normalization or data transformation by finding the log of all the attributes. So for example, I have 1 million, the log base 10 of 1 million will be 6. And can you imagine from 10 to 1 million, the difference is too much. But here, 10 will give me again 1 or 2. So normalization means that we are changing the value so that they will be close to each other. So this will be the conclusion of our lectures on data preprocessing. So as we mentioned earlier, data preprocessing is one of the important steps in data mining process or knowledge discovery in database system. Some of the tasks that are involved mostly is extracting and also sampling the data. Extracting and sampling the data. Now, after we sample the data, we may do data preparation, clean the data, remove the errors, which we use the term noise, find duplicates and remove them, replace the missing value with some value, etc. So again, wish everybody the best. And if you have any question, again, send an email. And thank you for your time.